Today's video is going to cover transversals of parallel lines in particular. You could have transversals with more than just parallel lines, but we're going to focus on the angle relations formed by a transversal when it crosses two parallel lines. Before we do that and talk about a transversal, let's review the concept of parallel lines. Parallel basically means that the lines are the same distance apart throughout its entire length. They run side by side and they will never ever touch. Parallel lines can run horizontally, vertically, diagonally. You can have more than two lines parallel. But for today, we're going to focus on dealing with two and a transversal. So what exactly is that word transversal? A transversal basically is a line that cuts, or in mathematical terms, intersects across two or more, usually parallel lines. So you might come across a time where you see a transversal intersecting across two or more lines that are not parallel. So it's important to make sure that you read the question. Here's one way that you might see it. You have your two parallel lines and your transversal intersects them. Your transversal in this case is that orange line. It's cutting across and intersecting the parallel lines. When that happens, you have special angle relationships formed. For our focus today, we're going to focus on when you intersect and we're just dealing with two parallel lines, you have basically 8 different angles that are created. You have 4 on the top with the first line and 4 on the bottom. Now, you're going to see this written a couple different ways. So if we take a look down here at this parallel line with transversal, you'll see the number 1 starts in this bottom corner. And then it numbers 2, 3, 4. What I want to show you is, notice this is drawn a different way and it's numbered differently as well. Here's a third example that starts from the right side, and the transversal runs with a positive slope. And then finally, here's another example of the numbering ordered differently. The reason that I'm showing you this is so that you understand you're going to get different examples. The order of those numbers aren't set in stone. You might even see variables when you are given this. You might not even see a number there. For our purpose, we're going to use numbers so that it's easy to identify the angle we are talking about. So let's start with corresponding angles. By definition, a corresponding angle, they're congruent. Congruent meaning they have the same measure. They equal each other. I say they sit in the same position. What does that mean? Well, if you take a look at angle 1, that is sitting above the first pink line and to the right of your green transversal. Then I go down to angle 5. That is sitting above the other parallel pink line and is also sitting to the right of that transversal. So 1 and 5 are corresponding. Another pair, if we look, angle 4. Well, angle 4 is below and to the right. So that must mean its corresponding angle is angle 8. Also below and to the right. That's what I mean by same position. So those two angles are in fact corresponding. My recommendation for those taking notes would be to get different colors. Okay, you're going to need 4 different color pairs so that you can highlight, just as I'm doing with the circles. You notice my first pairing when we did the other angles were blue. These are purple. Well, there's another set of corresponding angles. See, I'm using now a third color. This angle 2 sits above, and now it's to the left of my transversal. So another angle that is sitting above a pink line and to the left would be angle 6. So those are corresponding. Those have the same measure. And our last pair would be angle 3. It's below that pink line and to the left of my blue transversal. The other angle, you got it, angle 7. That is below the pink line and to the left of the transversal. So corresponding angles always have the same measure. Okay, so if I had angle 1, I could tell you the measure of angle 5. So we have not a new concept per se, because you do learn it, you've learned it in 7th grade, what vertical angles are. So vertical angles are just like corresponding. They're congruent. They have the same measure. They're basically opposite each other. That's one way to think of it. And they share a vertex. So that's just going to look a little different now in this whole picture of things. So what I have is angle 1. Its vertical angle is angle 3. Those two angles share a vertex. Their point is touching. They're opposite each other, and they have the same measure. Well, when we have this transversal cutting two parallel lines, that's not our only pair. So angle 2, what would be vertical to angle 2 and be equal to it? That's right, angle 4. You see how I keep changing my colors? And if you did this in your notes, you'd be able to see the different relationships. So these two angles have the same measure. There's another pair. Angle 5 is vertical to angle 7. Those two angles share a vertex and they have the same measure. Well, we've got one left, and that's angle 6. Angle 6 is vertical to, you got it, angle 8. They are in fact congruent, they are opposite each other, and they share a vertex. Okay, so before we can get into our next angle relationship, we got to go over the concept of exterior. When we talk about the exterior of our house, we're talking about the outside. Exterior, like an exit, you're going out, you're leaving. So think about that. The exterior is where you see the word exterior. It is outside those two parallel lines. So it's above it or below the two lines. So right where you see the words, those are what's exterior. So it's important to keep in mind what we're looking at. This angle relationship is called alternate exterior. So alternate, it means opposite, switch side. Basically, you alternate. Like think about a dance team. You have an alternate. Okay, it's someone that can step in and switch for that person. Exterior means outside. So when I look here, if I were to take a look at this concept, remember, congruent means they have the same measure. They're outside the parallel lines. Now here's a big thing. They are on opposite sides of the transversal. So I'm looking at exterior. That is leaving me with very little pairing here. So if I started with angle 1, okay, it's outside. Now I've got to go opposite, okay, and I'm going to go to angle 7. So it's on opposite sides. You know it can't be angle 2 because angle 1 and angle 2, those are supplementary. That's back from our 7th grade skill as well. You see that it is not a right angle, so those two angles are not congruent. So 1 and 7 have the same measure. Those two are alternate exterior angles. Well, with that pairing, I also have another one. Angle 2. Again, it is above the parallel line. It's outside it. So then I'm going to go on the opposite side, opposite position to angle 8. So therefore I know angle 2 and angle 8 are alternate exterior. Therefore they're congruent. Well, we have exterior, that leaves us with interior, inside. So you're now inside your two parallel lines. So your angles can really only come from inside. Okay, so keep that in mind. Now we're going alternate interior. So it's the same exact concept as the exterior, except we're not focusing on the numbers outside. So here I'm going to focus on the numbers 3, 4, 5, and 6, because those are inside. Again, they're congruent. They have the same measure. Okay? They are inside the parallel lines, and they're on opposite sides of that transversal. They're basically on opposite positions. So if I take a look at angle 4, well, that's it. That's to the right of my transversal. So opposite position would be to the left and below. So 4 and 6 are my alternate interior. There is another pair. You are right. Some of you might see it already. Angle 5 is going to match with angle 3. They're both inside. Those two angles there, they have the same measure. Okay? One more angle relationship that's formed is what's called same side interior. Same side interior is exactly as it sounds. Okay? These are supplementary. Their measures add up to 180. They are not congruent. This is our first pair that's not congruent. So it's important to remember that. They're inside the parallel lines and they're on the same side, same position. So let's look. If I had angle 4, what other angle is sitting inside those two pink lines is on the same side of the transversal and inside? That's right, angle 5. So if I had those two angles and I added them, their sum would be 180. Then I have angle 6 and angle 3. Those two are on the same side of that transversal and they're on the inside of the pink lines. They have the same positioning, so to say, of that transversal inside. So their measures add up to 180. All right, so what does this look like in action? Well, notice the problem. It says given M is parallel to N. That's exactly what that means. Find the value of X. Well, what do I know? What are they giving me? There's my X right there. It's at the top and to the left of my transversal. The only other thing I'm given, is angle 17. And that's at the bottom to the right of my transversal. So what is my step 1? Well, identify the angle relationship. So now that we're at this point, I've figured out what I'm given and I'm identifying the angle relationship. Well, the angles are outside the parallel lines, but they're sitting in different positions. So when we talk about outside, we're talking about, that's right, alternate exterior. They're outside, exterior. So I now need to remember, are they congruent or are they supplementary? Well, since they are alternate exterior angles, they are in fact congruent. So I know that they will have the same measure. Therefore, X equals 17 degrees. Pretty straightforward in a problem like this, right? Okay, well now it's your turn. So take a moment, pause it. I would sketch this in your notes and go from there. Okay, let's see how you did. Well, what am I given? I'm given an X here, and then I'm given 79 degrees. Okay, so I see that's the only information they've given me besides the lines are parallel. Well, I need to identify the relationship. These angles are inside the parallel lines. So now comes that step 2. Are they supplementary or are they congruent? Well, when we identified them, they're not same side interior. We know they're interior, but they're on different sides. So that left us with alternate interior. And from my definitions, alternate interior angles are congruent. So since I know that one angle at the bottom is 79, that must mean my x has to equal 79. Okay? So I'm going to give you a bit of a challenge here. And I want you to take a look at this. You know your angle relationships. Instead of just x equals, we now have expressions. They still want you to find the value of x. So what do I do? Okay. Well, if you pause the video and attempted this on your own, that is fantastic. Before you start, you got to decide, what do we have? What did they give us? Well, I have this angle is 7x plus 14. And this one is 9x minus 8. They're kind of sitting in the same position. Now, they're not both outside, they're not both inside. So that left us with corresponding. Now we know corresponding angles are congruent. Okay, so if they're congruent, they equal each other. And that's why I had said that earlier. They have the same measure, they're equal. So if I set those two equal, I'm now back to solving an equation. If you forgot how to do this with variables on both sides, you can pause this video and come back. There is another video on solving equations on the channel as well. But let's move forward. My first step would be to bring variables to both sides. So I'm going to bring 9x over. I'm going to subtract it from both sides. That's going to leave me with negative 2x plus 14 equals negative 8. Well, you know the next step is to bring the constants to the same side. So I'm going to subtract 14 from both sides, leaving me with negative 2x equals negative 22. I'm going to divide both sides by negative 2 to get x equals 11. So you have to be very, very careful now with positives and negatives, because they're asking you to solve for x. They're not asking you what's the angle measure. So in a process like this, you could get a negative number. So you just have to be careful and make sure you're checking your work. How do you check it? Plug 11 into both x's. The angle measures should be the same. If one of them is different, something went wrong in your solving. Okay. I have one more challenge for you, and then you guys can go off and practice. So take a moment, sketch it, and try it on your own. Okay. Let's see what we got here. I know this angle is x plus 14, and this is 4x minus 9. Now, as I'm looking at this, this is not any of the relationships that I've gotten in this video. But that doesn't mean we don't know this concept. I've kind of touched on it in this video. But remember, adjacent angles, so angles that share a side just like these two and form a straight line, those add up to 180. So I know these two angles are in fact supplementary. So if I were to take them and add them together and set them equal to 180, I could solve for x. So my first step is going to be to combine like terms. I have a like term of x and 4x. And then I have like terms of 14 and negative 9 to give me 5x plus 5. And then we have our 180. To isolate my variable, I subtract 5 from both sides. I now have 5x equals 175. Divide both sides by 5, so that x now equals 35. So there are so many different ways and different problems we can get with transversals and parallel lines. Dig deep into all your angle relationships that we've dealt with. If you have any questions, feel free to comment below or subscribe to see all the other videos that might help with each other.